Hey folks, welcome back to my channel where we learn to be a better programmer. And this is part 5 of the Java object-oriented programming tutorial where we're building out the game of chess. In the last video, we built out some pieces and like how we generate the valid moves for those pieces. And in this video, we're going to start to tie that all together. Okay? But before we get started, be sure to hit that subscribe button and turn on post notifications so you don't miss out on future videos. Okay, so we're in this board class that has a constructor where we're building out this board using a two-dimensional array of squares, and then we have it's built at construction time, and then we print out the location square map size. But what I want to do is actually implement this print board function, and it's going to help print it nicely for us so that we can re-render on every new move. Okay, so the way this is going to look like is going to say for int I is equal to 0, I is less than board squares dot length, I plus plus, and then for int j is equal to 0, j is less than board squares of I dot length, j plus plus. And we're going to say if board squares of I, j, that is occupied. If it's occupied, what we're going to do is we're going to get at that piece. So we're going to say abstract piece is equal to board squares of I, excuse me, I, j, dot get current piece. And then what we're going to do is we're going to say system.out.println, or print, sorry. We're going to print the piece dot get name dot char at 0 because we only want to print the first character, and then we're going to just add a space, whoops, like that at the end. Okay, and then otherwise, we're just going to print a dash, system.out.print, a dash with a space at the end. Okay, and then the first thing at the start of this loop, what we want to do is we want to say system.out.print, and we're going to print board length minus I, and then add a space to the end of that too. Okay, so what that's going to do is this going to just put the ranks on the left side of the board, and then every row we're going to print out whether there's a piece or it's an empty space. So like, let's just add a comment here, empty square. Okay, so that's pretty straightforward. Now, so then so this will fill out the contents of the board, and at the bottom of the board what we want to do is we want to put the file letters. So we're going to say for file in file dot values, and before actually we want to add some padding, so we're going to say system.out.println, and I think it's 2 spaces because we have the board length, then a space, and then the file should start right after that. Okay, so we're just going to say, or this is actually going to be a print, and after each line here we're going to say system.out.println. So this will just add a new line at the end of it. Okay, and then so for file in files, we're going to say system.out.println file.name, or not print line, print, and we're just going to add a space, and we're going to say system.out.println. So just add another line at the end of it. All right, so in the game class, what we're going to do is we have our board, and then we're going to just call print board. And if we run this, you see that it printed out nicely. Okay, awesome, cool. So now, as you can see, we have an empty chessboard with no pieces, so that's not very helpful. So what we're going to do now is we're going to create what's called a piece factory that's going to allow us to initialize the board with the pieces that belong on particular squares. All right, so let's create a new Java class in the board, actually in the piece piece package. We're going to say new Java class, and it's going to be piece factory. We could probably name it something better, but this is fine. So we're going to set public final class, and it's going to just have a private piece factory constructor, because we don't necessarily want this to be constructed, and final because we don't need this class to be, we don't want this class to be able to be inherited from. Okay, so what this is going to look like is going to say public static map of location to abstract piece, and this is going to say get pieces, and then all we're going to say is we're going to say map location abstract piece pieces is equal to new hash map, like that. And all this is going to look like is just going to say, so we're going to start with the rooks. So the rooks are then going to say pieces dot put. So the rooks are at locations A1, H1, A8, and H8. Okay, so we just need to say new location of, let's see, location constructor should have a file, so A, and then 1, and then new rook, and then the piece color is light. Okay, so we're just going to copy this a few times, and so this is going to be A1, H1, A8, H8, and then this is a dark piece here, like that. Whoops. Dark piece. Awesome. So those are the rooks. And then we can say knights are next, so that we can just copy this, put it here. And then it's not going to be A, but it's going to be B, G, B, G. And this is a knight. Oops, not a king, but a knight. And we can copy this. Oops. This is a knight. All right, cool. All right, so that's knights, and then we can say bishops, like this. Let's say bishops. And this is going to be C1, F1, C8, F8. And then piece type is a bishop, like this. Okay, and so after the bishops, it's actually going to be queens. So we're going to say queen. Whoops, not Q, queen. And I'm going to say pieces dot put new location of file. So queens are always on the D file, and rank 1, and the new queen piece color is light, like that. And D file on rank 8, and the piece color is dark, like that. And whoops, Command Z, what did I do? Oops, let's see. And then the kings. All right, so the king starts out on the E file, like that, and this is a king, like so, and then we have the pawns. All right, so the pawns are pretty straightforward. You can just do this in a loop, so we can say for file in file dot values, and all we're going to do is we're going to say pieces dot put new location of file, and it's going to be 2, and then new pawn piece color light, and then on the other side for dark squares like this, dark. Nice. All right, and then we're just going to return pieces. Awesome. All right, so now we can use this to fill our board with our pieces. So if we go back over to board, now what we can do is inside of the constructor, we can say map location abstract piece, pieces is equal to piece factory dot get pieces, like so. And the way we do this now is we need to actually put the piece on the actual square. So what that looks like is we say if pieces dot contains key new square dot get location. Now then we say new square dot set current piece to the, all right, so first actually let's just pull the piece. So we're going to say abstract piece is equal to pieces dot get new square dot get location. So we're going to set the new square's current piece to piece. New square dot set is occupied, set occupied true, and then we need to say piece dot set current square to new square. All right. Now, when we run the game function, we should actually see our board filled. So let's see what happens here. Awesome. So we're missing this rook. So it looks like I copied and pasted incorrectly. So let's see. Piece factory, rook A8, and this is H8. All right, so let's rerun this. Cool, awesome. Okay, so we have this board now filled with pieces. The next thing that we're actually going to do is in the board class, we're going to just have some helper methods to get the light pieces. So what we're going to do is we're going to have two lists. So we're going to say private final list abstract piece light pieces is equal to new array list, and then private final list abstract piece dark pieces is equal to new array list, like that. All right, so then we're going to say if piece dot get color get piece color dot equals dark, then we're going to say dark pieces dot add piece, and then else light pieces dot add piece. All right, and we're going to have some helper methods. We're going to say public list abstract piece get light pieces, and then we're going to say return light pieces, like that, and public list abstract piece get dark pieces, and we're going to say return dark pieces, like that. Okay, awesome. All right, cool. So let's go over to game, and then we're going to say board dot, or let's just board dot get light pieces dot string dot for each, and then piece, and then all we're going to do is just to say system dot out dot println abstract piece, like that. All right, and then I think we can collapse this to a lambda, which is nice. Okay, so we run and we expect that the piece should get printed out. So do we have two knights, two bishops, a queen, a king, and a rook? Awesome. And we should have 8 pawns. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay, moving right along. So okay, so now what we want to do is, let me just remove these because we don't need these anymore, or this. Okay, so all right, so we need to actually implement a way to receive moves from user input. So the way that's going to work is we're going to say scanner is equal to new scanner of system.in. And then we're going to say while true. Basically, this condition, this true condition would be true, it would be replaced with while game is not finished. So we'll have some checker to verify that there's no like end condition in the game. So draw, checkmate, all that kind of stuff. But we'll do that in a later video. So what we're going to do is we're going to say, we're going to read in stuff from the command line. So the input is going to look something like, so if we're going to move a piece, we're going to say like the starting location to the end location. So from to, so it's going to say like E2 to E4. Okay. So what this is going to look like is we're going to say string line is equal to scanner.next. I think next line is fine. So then we're going to say string array is equal to moves is equal to, or say from to is equal to line dot split, and then we're going to split it on that arrow. Okay, so now we need to pull out this, the file and the rank from this input. So we're going to say file from file is equal to file dot parse, oops, not Java IO file, yeah, file dot value of, and then we pass in the from. So we're going to say from to of 0 dot char at 0, and then we have to do some weird stuff in here. So we have to say string dot value of, or actually, you know, we can do character dot to uppercase, dot to string. Wait, am I doing something? Yeah, let's just wrap this and say string dot value of, and then like that. Oh. Okay, so what we're doing is, I'm sure there's a better way to do this, but this is fine too. So we're taking the first, or the from, the first character, the from, and then we're converting that character to an uppercase because we want to handle a case if they just put in a lowercase or an uppercase, and converting that character to a string, and then file, it will convert that string into the actual file. All right, and then we're going to do int from rank is equal to integer dot parse. Yeah, we can't parse from a character directly, so we're going to say integer dot parse int from character, actually string dot value of from to of 0 dot char at 1. So this is actually pretty flimsy because, you know, like we're not doing any range checking or anything on the string, but this is just for testing purposes for right now. All right, so we have, and then I'm just going to rename this to file and then to rank, and so this is actually, we need to just change this to 1 and 1. All right, so now that we have a rank and a file, we need to actually make the move on the board. So we're going to say board.get location square map dot get. Okay, so get new location of from file from rank. So that's going to give us a square, square from square equal to that. And then we're just going to say here to square. And then we should do some, like, again, checking, but This is, again, just a quick and dirty test to make sure that our logic is doing the right thing. All right, so now, so we have the from square and the to square, so we need to get the piece on the from square. So we say from square dot get current piece dot right. So there's a problem here because we are pulling in an abstract piece instead of the actual movable interface. So to get around this, what we can actually do is we can just say implements movable, and that should give us access to the methods that we have. So we can say make move, and then we can say to square. All right. Now, but then we also need to deregister the from square. So we need to say from square dot set occupied false, and then from square dot set current piece is, or actually we could just call reset. Nice. Okay, like that. Okay, so we can test this, and then we're just going to say on every iteration of the loop, we're going to say board.print board. Cool. All right, so let's run and see what happens. So it's expecting an input, so I'm going to say E2 to E4. Nice. We saw that that pawn moved from E2 to E4. Awesome. Now let's try another one. So let's make a move for black. So we're going to say E7 to E6. Oh, and you look at that. Cool. So we're actually making some really nice moves here. Now a few things. We just want to clean up a few things here. So I'm going to remove this logging statement from here. Okay. So in this video, what we did was we implemented a piece factory and we filled our board, and we can now have a very simple game loop that's actually super flimsy. But overall, it actually does what we're trying to accomplish. All right. In the next video, we actually need to implement some more logic here to make moves and get valid moves for each of these pieces, and we'll do that in the next video. If you like the video, please feel free to hit that like button and subscribe so you don't miss out on future videos. Thanks.